Hi there, it's Mrs. Tremblay. Welcome to Chapter 5, first lesson, 5.1. It's all about similar figures. What are similar figures? They are figures that have the same shape, but not necessarily the same size. And I guess you can think about similar figures as being shapes that are proportional to one another. So they're not necessarily the same size, but they're scaled up or down by the same amount. For example, maybe you've gone to the store to purchase a t-shirt. The shirt that you want comes in different sizes, right? Small, medium, large, extra large. Well, to get from the small to the medium, they basically will scale up all the dimensions. Like, what if they forgot to scale up the sleeves? And then all of a sudden, we have these tiny little sleeves on the extra large. It just wouldn't work. So those t-shirts are similar because they're scaled up or down by the same exact amount. So now instead of t-shirts, we're going to talk about shapes. And we have to determine if shapes are similar or not. So we talked about similar figures being proportional. Two figures are similar if their corresponding side lengths are proportional and their corresponding angles have the same measure. That word corresponding could be new to you. If it is, let me tell you what it means. Corresponding basically just means the sides and the angles that match up. It's the one that's in the same spot. So if I was talking about a shirt, I would match up the right sleeve with the other right sleeve. Same kind of idea here, except we're talking about side lengths. So the first thing we're going to do is practice this corresponding parts, because if we can't identify the corresponding parts, we're not going to be able to figure out if they're proportional or not, which is our goal. All right, so first off, naming corresponding parts. I have two examples here. In the first example, this one's kind of nice. They're in the same exact position. The next one will show you they don't always have to be. But these trapezoids here are similar. So I'm telling you off the bat, they are similar. We're not trying to prove that right now. We just want to be able to name all the corresponding sides and angles. And there's a certain way we're supposed to list that, and I want to make sure you're familiar with that. Okay, so right here, we're going to start with angles, the corresponding angles. And I see that these are in the same exact position. So this angle A right here, on this other trapezoid, P is in the exact same position as angle A. So we're going to say for corresponding angles that angle A and angle P are corresponding. The way to list an angle is you draw a little angle in front of it, angle A and angle P. So they match up from one shape to the next. Next we'll do B, and I'm going to use two little rings here, and I'll use two little rings here with a Q. B and Q match. So I'll say angle B and angle Q. Then go to C, 1, 2, 3 arcs I'm going to use. 1, 2, 3 arcs. And angle C and angle R match up. And then of course we have D, I'm going to use 4. 1, 2, 3, 4. And 1, 2, 3, 4. Angle D and angle S match up. A common error with this, make sure that you start from this shape and go to that shape. You can't say angle A to angle P and then here say angle Q to angle B. Make sure you're always starting with the same exact shape. All right, next we want to do the corresponding side lengths. So with the corresponding side lengths, if you look, if I'm going from A to D, the matching side length on the other shape would be from P to S. So all you have to do to list that is you call side length AD, AD. And matching up with that is PS. Notice I started up here and went down from A to D. Make sure you start from P to S. You wouldn't say AD and then SP. That would be backwards. You don't want to do that. All right, let's pick another side length, any side length. How about this one? AB. So this time it's AB. And AB matches up with PQ. Notice A to B. We're going to start here, P to Q. You could have said BA if you want, but then you would have had to say QP. However it works for you. All right, another side length is DC. I'm going to list DC, and DC matches with SR. And the last pair of matching sides, I'm going to go BC. So if I start up here from B to C, that means I need to start here and go from Q to R. All right, hopefully so far so good. Now we're going to try one more of these, except this time it's a little bit different because as you can see, these two triangles are not in the same exact position. So it makes it a little bit trickier when you're trying to match up all the corresponding sides and angles. What you might want to do is redraw one of these so that it is in the same position. So what I mean is, I would say, okay, well, this one right here, it's upside down. So underneath, I'm going to draw, I want it to look like this so that it matches the other, where there's a really short side, a longer side, longest side. So as you're looking, this shorter side length, this is upside down right now. If you flipped it over, this X would be on the top and Y would be underneath it, and Z is what we have left. Doing that, drawing that over again, will make things a lot easier for you when you're trying to match everything up. So let's do that. Let's match it all up. And if you wanted, you could hit pause right now and try to do this one on your own and hit play when you're done and see if you did it right. That would be a good idea. Okay, let's start by listing all the angles. And remember, when we list our angles, we have to use a little angle sign in front of it. So right here, this angle A, that's going to match up with, on this shape, angle X is in the same position. Again, if we were looking at this shape, it might be a little bit more difficult to identify that. But by redrawing that the exact way that that one's listed out, it's helpful. So angle A, and I'm going to use the and sign this time, and angle X. Those ones match. And here's angle B. Angle B is in the same spot as angle Y. So angle B and angle Y. Notice I didn't say YB. It has to go in the same order. I'm going from this shape to this shape. And finally, angle C, that's going to match up with angle Z. And now we have our side lengths to match up. So again, we're going from A to B, AB, and I wouldn't say YX, I would say XY. And then we have a BC. BC, I just used two different and signs. Wow, it's exciting. YZ. All right, and then our last one, I'm going to go from A to C. If I go from A to C, that means I have to go from X to Z. I can't go from Z to X. The order must be the same. Okay, so hopefully we now know how to match up corresponding sides and angles, and we know what that all means. The next part of this is being able to use that information. So down here it says identifying similar figures. That's actually the goal of this lesson. We want to be able to look at two figures and determine, are these actually similar? So again, similar figures have the same shape, but they're not necessarily the same sides. And we had said earlier that their corresponding sides are proportional. So remember, shapes are similar if their side lengths are proportional. To determine if shapes are proportional, write the corresponding sides as ratios and see if they simplify to the same thing, have the same unit rate, or have the same cross products. Remember, when we were determining if a proportion was in fact a proportion, we had three different ways, and the same three ways apply here. Okay, so here are two rectangles. Notice that they're not in the same exact position. That's all right. You could redraw it in the same position if you want, or I'm going to try to just match up. Okay, so I see this side length here. This is a 10. Right? Side length 10 is the longer side length of the two. So the side length on this shape that would match up would be the 4, because that's the longer side length of the two. So when I say set up a pair of ratios, I'm going to set up to start 10 to 4. All right. Now I want to know, since we're setting up a little proportion here, if 10 to 4 is equivalent to, now I have this other side length here, 6. That's the shorter side length. That's going to go with a 2.4. Okay, so notice a couple things to notice. I went from this shape to this shape, right? So I put the 10 to the 4. I couldn't put 2.4 over 6. I have to start with the same exact shape. So the numerators both represent the first rectangle. The denominators both represent that second rectangle. So determine if these two shapes are proportional or similar. They mean the same thing. I said that you could see if they simplify to the same thing, have the same unit rate, or have the same cross products. You can use any way. And I'm going to tell you that for this, honestly, finding the unit rate by just dividing the numerator by the denominator is, I think, the easiest way to go with these. So if you take 10 divided by 4, you get 2.5. If you take 6 divided by 2.4, you also get 2.5. Because they both have the same unit rate, that means that yes, those two rectangles are similar. So that means if this was the large shirt, that we scaled all the dimensions down to make the small shirt, not just the sleeves, or not just the length, and not just the neck. If you wanted to use, I'll show you the other ways, but you don't, on your homework, you wanted to do all the ways. I just want to show you how it all works. If you wanted to, you could have done cross products. 4 times 6 is 24, and 10 times 2.4 is 24. So I know that those ratios are proportional, and again, proportional and similar mean the same exact thing. You could have also simplified this if you wanted, and if you would simplify these, both of these would end up simplifying to 5/2. It's a little harder to see when you have a decimal within a fraction. So that's why for this one I would just use the division. So the answer is yes to this because those two ratios form a proportion. Okay, when you look at the next one, you might notice a little bit of a difference here because usually when we set up our proportions, we just have two ratios, right? Well, there are 3 corresponding side lengths here. And you have to make sure that all of them are equivalent to one another, not just 2. You need to test every single side length. So we could look at this as the length of the shirt and then each sleeve. What would happen if you only scaled up one of the sleeves and not the other? Then you'd have a problem, right? Unless the shirts are supposed to be designed that way, which I don't think so. So with this, we're going to set up all of the ratios of the corresponding sides. And then we can use unit rates to see if they're equivalent. So again, if you see all 3, you need to do every single side length given. So let's match up some sides. It doesn't really matter which one you start with. I'm going to start with the shorter side of this triangle. So it's 3. When you look at this, these aren't in the same position, but 3 is the shortest side length. Do you see that 6 is the shortest side length here? Those match up. Those are corresponding sides. Your ratios need to be corresponding sides. So I want to see if that is equal to, now let's pick another side here. All right, I see a 7 here. So I'm going to set up a 7. And on this shape, this isn't the hypotenuse. This down here is the side length that matches. So I'm going to put the 21 with that. And now we have 1 left. This is the hypotenuse. I want to see if 5 goes with the 15. Okay, so in order to determine if these shapes are similar, all of these ratios need to simplify to the same thing or have the same exact unit rate. So you could simplify all of those if you want. Honestly, with this one, I would totally want to do that because I can see this in my head right now. What 3/6 simplifies to, what 7/21 simplifies to, what 5/15 simplifies to. And if you're doing it that way, you see that this is a half, this is a third, and this is a third. Now, when shapes are similar, all the side lengths are proportional, not 2 out of 3. So it needs to be all 3. So this would be a no if you're using simplifying. I know that not everyone is a fan of simplifying fractions. I know that we're really savvy with dividing the top by the bottom in our calculator. So if you were to do that, and you took 3 divided by 6, you would get 0.5. If you took 7 and divided it by 21, you're going to get 0.3 repeating. And if you take 5 and divide it by 15, you're going to get 0.3 repeating. So because this one is different than the others, it means that no, these shapes are not similar. So again, in summary, because it's going to be your job to determine if the shapes are similar or not. Sorry, my foot hit the camera. In summary, if you want to determine if shapes are similar or not, all you need to do is match up their corresponding sides, set them up as ratios, and see if all of the ratios are equivalent, meaning proportional. And if the side lengths are proportional, that means your shapes are similar. We are done.